Hello everyone, welcome to 8.8. We talk about power series. A power series is an infinite series, so it's a sum of an infinite number of terms. And notice it's number x squared, number x cubed, number x to the fourth, number x to the fifth, and it goes on forever. And we say it's centered at 0 because it's just plain x. We could center it someplace else, x minus whatever. Think back to your transformations from algebra. This moves it left and right, however many spaces opposite of the sign. We already know a power series. 1 plus x squared plus x cubed. We talked earlier about how this is a geometric series with a sub 1 is equal to 1 and r is equal to x. So it's a sub 1 over 1 minus r, or 1 over 1 minus x, as long as x is less than 1. So we say that the interval of convergence is between what two numbers? Well, what kind of numbers are those? X has got to be less than 1 and greater than negative 1. So that's a geometric series, is a power series. Let's find a power series for this. Well, the top number was my a sub 1. And this should be 1 minus r. So a sub 1 in this problem is 1. But if it's 1 minus r, but I have 1 plus x, then what's my r? In this case, it's negative x. So how would I write this one? 1 minus x plus x squared minus x cubed plus x to the fourth. And it goes on like that. You also have to be able to write the general term. In the general term, there's lots of different ways to write it. And it doesn't matter where you start. The first thing I see is that it alternates. So I'm going to put negative 1 to the n in there to make sure it alternates. I can make that bigger, sorry. Does that work? If you plug in 0, you get a positive. If you plug in 1, you get a negative. If you plug in 2, you get a positive. So that part's good. Now what about the powers on x? No x, 1x, 2x, 3x, so it's x to the n. So that's your power series, and that's the general term. Okay? Let's take a look at this one. This is a sub 1, and this is 1 minus r. So a sub 1 is x, and r should be negative, so it's negative x. So let's write this out. The first term is x. Now I'm going to multiply by negative x, by negative x, by negative x, by negative x. And you can see the pattern. Let's write the general term. Again, there's more than one way to write the general term. You don't have to start at 0. I usually start at 0 just because it makes sense to me. It alternates. So I've got to put this in here. Now let's check and make sure that works. Plug in 0, you get a positive. Plug in 1, you get a negative. Plug in 2, you get a positive. Plug in 3, you get a negative. So that works. Is that going to work for my x powers? X to the 0, x to the 1, x to the 2. We're close, but I need to have 1, 2, 3. That's 0, 1, 2. So it's n plus 1. That's the power series. And that's the general term of power series. Let's take a look at this one and find the interval of convergence. Well, a sub 1 is equal to 1. R is equal to 2x. Let's stop for a second and find that interval of convergence. I know that r has to be between 1 and negative 1, which means 2x has to be between 1 and negative 1. That's telling me that my interval of convergence is between negative 1/2 and positive 1/2. So the interval of convergence is negative 1/2 and positive 1/2. Okay? Let's make my pattern. 1 plus 2x times another 2x is 4x squared, times another 2x is 8x cubed, times another 2x is 16x to the fourth, and on and on and on. So, let's figure out the general term. It doesn't alternate, so I don't have to worry about that. The first term is 1, and I'm multiplying by 2x every time. Let's make sure that this form works. If you plug in 0, 2x to the 0 is 1. 2x to the first, 2x. 2x second, there we go. So there you have it. Okay? Well, let's go back to this problem real quick. We should also check the endpoints and see if -1/2 works or if 1/2 works. I put parentheses around them because I knew the answer. But let's check x equals -1/2. If I do that, 2 times -1/2 is -1 to the n. Does that converge or diverge? That diverges. Why? Because it's -1 plus 1 minus 1 plus 1 minus 1 plus 1. What if x is equal to 1/2? 2 times 1/2 is 1. Does that converge or diverge? Well, that's 1 plus 1 plus 1 plus 1 plus 1 plus 1, and that'll go forever to infinity, so that diverges. So I can't use -1/2 and I can't use +1/2. I have to use everything in between. Let's take a look at this one. A sub 1 is equal to, the top is 1. R is equal to, that should be minus, so it's negative x minus 1 or negative x plus 1. Let's find my interval of convergence. Well, I know that negative x plus 1 has to be between 1 and -1. That makes negative x have to be between 0 and -2. Divide everything by negative, that makes that a +2 and that a 0 still. I switched my signs because I divided by a negative. So it's got to be between 0 and 2. And I'm not going to put brackets or parentheses around it until at the very end when I check it. So, let's do some writing. The very first term is 1 times negative x minus 1 times negative x minus 1 squared, but if you squared it, it's going to be positive, minus x minus 1 cubed plus x minus 1 to the 4th. You can see the pattern. So let's write the general term. Well, it alternates, so let's start out with that. Make sure it works. Plug in 0 is positive, 1 is negative, 2 is positive, so that works. What are you multiplying by each time? X minus 1 to the nth power. Check your endpoints. If you plug in 0 for x, I would have, so if x equals 0, that's -1 to the n times -1 to the n. That's going to be 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's divergent. What if x equals 2? Then I'd have -1 to the n, +1 to the n. That's going to be -1, +1, -1, +1. That's also divergent. So neither 0 nor 2 work. So my interval of convergence is from 0 to 2, not inclusive. Uh-oh. That's got squared around it. How does this, which we're trying to find, relate to this in calculus terms? Well, this is 1 minus x to the -2. This is 1 minus x to the -1. How can I get from this to this? I'm going to take the derivative of both sides. I can take the derivative of the left side as long as I take the derivative of the right side. The derivative of the left side is 1 over 1 minus x, quantity squared. It's what we want. So now let's take the derivative of the right side. 0, 1, 2x, 3x squared, and keep going. So I took a derivative of both sides. That's legal. So the thing I'm trying to find is this. How did I do that? I took a derivative of the 1 power series I knew. The general term of that is n plus 1, x to the n. What if I want the natural log of 1 over x plus 1? Well, how do these things relate? Well, I know this is 1 minus x plus x squared minus x cubed. Why do these alternate? Because that should be minus x and it's plus x. So how do I get from this thing that I know to this thing that I want in calculus terms? I integrate. The integral of 1 over x is the natural log of 1 over x. If I integrate the right side, I get t, or x, whatever you want to call it, x squared over 2, x cubed over 3, and so on and so on and so on. So now the thing that I wanted to find is this. It's the integral of the thing that I already knew. In notation, since it alternates, it's negative 1 to the n. X to the n plus 1 over n plus 1. Make sure this works. That's x to the first over 1. That's x squared over 2. That's x to the third over 3, and on and on and on. So what am I saying here? I'm saying you can take a power series and you can take the derivative of both sides and the integral of both sides to find a new power series. That does it for power series. It's one of the more complicated topics we do because it's unlike anything you've ever done before. We're going to spend a lot of time practicing this, so if you have any questions, come talk to me. Good luck, guys.